Today we're going to look at radian and degree measures. So degrees you're probably pretty familiar with. It's radians that we're going to take a big look at today. So a radian is based off the radius of a circle. Okay, so if we look at this circle here, we're just centering it at the origin. And we want to know how many radii, which is the plural of radius, how many radii does it take to go around the circle? So if I measure the radius of this circle here, okay, so I'm just going to take this little purple length right here and measure that same distance around the circle. So these are about equal. I'm obviously just eyeballing it, so it won't be perfect. Okay, but this length matches this length. So this is one radius. Then I'm going to measure that same distance. That'll be 2. That'll be 3, so I'm about halfway with 3. This will be 4. 5, and then 6 will get me right here. So we have 6 and just a little bit more. Okay. So if we're trying to think about exactly how many radii that takes me, we know it's estimated about 6 and a little bit. Well, if I think of my circumference formula for a circle, since we're dealing with going around a circle, we know that circumference is equal to 2 pi r because it takes 2 pi radiuses to go around the circle. So when we're trying to figure out how many radii it takes to go around the circle, that is exactly 2 pi. So this little bit right here is about 0.28. Okay, if I look over here, when I counted to that third radius, okay, so to go halfway around, that's about pi. It's not about pi, it's exactly pi. So all the way around a circle takes 2 pi radii, halfway around takes only pi. So that's what our radian is based off of. Okay, so a radian is the measure of an angle whose intercepted arc is equal to the measure of a radius. So here's the radius here, okay, and that first little mark I did on that last picture, okay, this was the same. So what a radian is if I draw an angle from the center, this angle right here, that is 1 radian. So I'm going to call this theta. We use theta to abbreviate angles a lot. Okay, so this angle, we pretty much always measure them from the x-axis. So from the x-axis to this line at that first radius mark, that is the equivalent of 1 radian. So where a circle is broken up into 360 degrees, so you would just take this circle and have it split up into 90 teeny little angle measures per quadrant. If we're dealing with a radian angle measure, okay, our circle is going to be broken up into 2 pi radians. So if I jump back to this picture, here's 1 radian, 2 radians, 3, 4, 5, 6. So these are all 1 radian, and then you have this little part right here, which is about 0.28 of a radian. So to go all the way around, just like our circumference formula, all the way around a circle is 2 pi radians. And radians don't have a unit. Like with a degree, we put a degree symbol. A radian, it's still an angle measure. It's just another way of measuring an angle. Like you can measure a distance in inches or centimeters. You can measure an angle in radians or degrees. Okay, so all the way around a circle is 2 pi. Okay, so halfway around is just going to be pi. Halfway of halfway. So if halfway around is pi, half of halfway is going to be 1/2 pi, which we typically write as pi over 2. Okay. So let's just look at some radian measures. Okay, so we know 2 pi, that was all the way around. So 2 pi was a full circle. So 2 pi, that's going to be equal to 360 degrees. Okay. Well, pi is halfway, or half of 2 pi, so half of 360, 180. 0 is just 0. So make sure when you're dealing with degrees, you need to write the degree symbol. when you're dealing with radians, there's not a symbol for radians. It's just unitless. Okay, so this little measurement right here, pi being equal to 180 degrees, this is kind of what we use to convert a lot of the times from radians to degrees. So when you see pi, you should be thinking 180 degrees. So if I want to know how many degrees pi over 2 is, that's 180 over 2, which is 90 degrees. Then 180 over 3 would make pi over 3 equal to 60 degrees. 180 divided by 4, that'll be 45 degrees. So pi over 4 is equal to 45 degrees. So these are equivalent angle measures. Like 12 inches is equivalent to a foot. Pi over 4 radians is the same measurement as 45 degrees. Then pi over 6, that's 180 over 6, which is 30 degrees. So these are the ones we use most often. If you look right here, these are our angle measures in special right triangles. So these guys will show up a lot when we're dealing with radian measures. These over here we don't use as often, but they do come up occasionally. So pi over 9, remember pi is equal to 180 degrees, so 180 divided by 9 would give us 20 degrees. 180 divided by 10 would give us 18 degrees. 180 divided by 18 would give us 10 degrees. And pi over 180, that's 180 over 180, that would be 1 degree. So this right here, I use these the most. Okay, so these are very common. This I use when I'm stuck. Use when stuck. So we're going to kind of use these to convert from radians to degrees and degrees to radians. So let's look at a couple examples. Okay, so remember, anytime you see pi, you're thinking 180. Okay, so these right here, these are 3 radian angle measures. If we're going to convert them to degrees, okay, what we're thinking of, and I'm not usually writing this out, you should be like quick to convert. So when I see this, when I see pi over 3, I'm thinking this is 4 times pi over 3. So this is 180 over 3. So that's 4 60-degree angles, which would be 240 degrees. So this little part right here, I don't usually write it out. Okay, at the beginning, if it's going to help you to write out the arithmetic, that's fine, but we want to be quick when we're converting from radians to degrees. Okay, so I isolate this part, and I think 180 over 3, well, that's 60-degree angles, and we've got 4 of them. So in my head, I'm doing 4 times 60 to get 240. So here, pi over 9, I'm thinking 180 over 9, which is 20. So this is 8 20-degree angles, which would be 160 degrees. So this means 8 pi over 9 radians is equal to 160 degrees. Okay. Now, one like this. Okay, this is a weird one. This is 180 divided by 36. Okay, sometimes I can't do that math in my head. So off to the side, I'll usually just do 180 divided by 36, and I'll reduce it until I get to something I know. So I'm going to divide everything by 2. That'll be 90 over 18. I'm going to divide, this time I can divide everything by 9, so that'll be 10 over 2, which is 5. So this is 7 5-degree angles, so 7 times 5 is going to make that 35 degrees. Okay, so I don't always know what this is. So if that's the case, I'll work it out. But most of these are going to be pretty simple arithmetic. So 180 over 3, 4 times 60. This part right here, eventually, if you're not doing this now, you would want to be doing this mental math. Okay, so now let's go the other way. Okay, this is degrees, and we want to convert them to radians. Okay, this, in my opinion, is not as easy as the other one. Okay, so typically I want to break it up into 30, 60, 45, sometimes 90 degrees. So I usually want to use those special right triangle angles. Okay. So when I see 210 degrees, I'm thinking, okay, that's 7 times 30 degrees. Okay. Well, 30 degrees, remember that's pi over 6, okay, because that's 180 divided by 6. That'll generate this 30-degree angle. So since I can break 210 up into 7 times 30, that means that is 7 pi over 6 radians. So 210 degrees and 7 pi over 6, those are equal angle measures. Okay. Now 300, I can break that up into 10 times 30, okay, but I could also do 5 times 60. So if there's multiple ones of these that work, you want to pick the bigger one, okay, because you're going to have less reducing. Okay, so 60 degrees in radians, okay, so that's going to be pi over 3. And I remember that because pi is equal to 180, so 180 over 3, that's what gives me the 60-degree angles. So 300 degrees is going to be equal to 5 pi over 3. Okay. Now, if you didn't realize 60 went in there and you did 10 times 30, 30 is pi over 6, 180 over 6 is 30. This is going to reduce to 5 pi over 3. Okay. Now 270, I'm going to use 90 degrees on this one. Okay, so I also probably should have put 90 degrees on this list. Because 90, that's half of 180, so that's pi over 2. Okay, so this angle measure right here, you're always figuring out it's 180 divided by what? That's how I'm figuring out the denominator. So 90, since that's half of 180, that's a pi over 2. So 270 will be 3 pi over 2. Okay. Now this one right here, 48 degrees. I mean, that's 6 times 8, 4 times 12, but I don't really know what those are in terms of pi over something. So when I get a weird number that doesn't easily break down into something that I know, like the 30, 60, 90, or 45, that's when I use that 1 degree. So this is 48 1-degree angles. Okay, remember, 1 degree, that was pi over 180. Okay, because this is 180 divided by 180, which is 1. And then from here, I'm just going to reduce it until I can't reduce anymore. So I'm going to divide everything by 6. So that'll be 8 pi over 30. Then divide by 2. That'll be 4 pi over 15. And then I cannot reduce anymore.